Okay, we've talked about parametrics and arc length. Now we're going to talk about parametrics and surface area. So surface area is the idea that if you rotated a graph around the axis, what would the surface area of it be? What would the area of that entire figure be? So we have two formulas we need to know. If you're doing surface area around the x-axis, it's S equals, surface area equals 2 pi, your integral from a to b, so those are your points, and y of t times the arc length of that figure. I'll get to why it's y of t and x of t later. Around the y-axis, it'd be S equals 2 pi, integral from a to b, x of t times the arc length of that figure. So the reason why we want to use y of t around the x-axis and x of t around the y-axis is because these are your radii formulas, and you're multiplying it by arc length, and that'll give you surface area. So let's do an example, that'll make more sense. Example 1 says find the surface area rotated around the x-axis, and they've given you x equals 2t squared, y equals 3t cubed, and it's on the intervals 0 to 1. If you find the derivative, so dx dt equals 4t, and dy dt equals 9t squared, because it's being rotated about the x-axis, you want to make sure to keep this y formula in mind. So you have s equals 2 pi on the integral 0 to 1 of y of t, so that's 3t cubed, times the arc length of this graph, so that's 4t squared plus 9t squared, I forgot the squared there, dt, and that should come out to about 32.14 on a graphing calculator.